Venn diagrams were invented by John Venn and first appeared in print in 1880. They are very, very useful in showing relationships among sets. In order for me to talk about it, I thought it might be easier if I made up an example that had nothing to do with math. Yay! Example number 1 was set at Sunrise Day Camp. Campers can sign up for special activities like kayaking or rock climbing. Bunk number 1 had 8 campers whose names appear here. I put Alex, Ben, Ethan, Frank, and Harry in kayaking, and Ben, Carl, George, and Harry in rock climbing. Here's how this information might appear in a Venn diagram. The Venn diagram is framed with a rectangle, and the U stands for universal set, which in this case is bunk 1. Inside are 2 circles, kayak circle and a rock climbing circle. Inside the kayaking circle, I put all the kayaking names. Inside the rock climbing circle, I put all of the rock climbing names, as I wrote down over here. Alex, Ben, Ethan, Frank, and Harry are all somewhere in the red circle. Ben, Carl, George, and Harry are all somewhere in the green circle. What I had to be careful about was how to handle Ben and Harry, because Ben and Harry are in both circles. So I put them in the center so that they're part of the red circle and they're also part of the green circle. And I made their names brown because I looked it up on the internet, and red and green make brown. See that? Brown. How cute is that? David is outside of both circles because although David is in bunk 1, little Davy didn't sign up for any activities. So there he is, sort of out in the cold. You'll notice also that the circles are often used with single letters. A and E for Alex and Ethan, F for Frank, R for rock climbing, K for kayaking. We can now learn 2 of the 3 concepts that are often used when diagrams are used: union and intersection. Many of you may have learned union and intersection when you were working in geometry last year. The union of the kayak circle and the rock climbing circle are all the campers who signed up for kayaking or rock climbing. As long as you signed up for something, you're in the union. So I showed you kayaking and rock climbing list again, just so you won't have to turn the page. And what we did was we shaded in the Venn diagram, shading in all of the K circle and all of the R circle together, showing that everybody that was in K, everybody that was in R, as long as you're in one or the other, you're part of the union. And the letter U stands for union. The intersection of K with R, with an upside down U, which is sort of reminiscent of an N for intersection, have all the campers who signed up for both kayaking and rock climbing. If you aren't in kayaking and rock climbing both, that means Ben and Harry, you're not in the intersection. So what we did was we shaded in the section of the Venn diagram that was part of both circles, and that's what the intersection looks like in a Venn diagram. I don't want you to think that Venn diagrams always have these 2 little circle rings, one crossing over another. So I made an example for Sunrise Day Camp, which included circles that don't overlap one another. I made a list of campers by their age, with 15-year-olds and 16-year-olds. I also made a list of campers by their home addresses, whether they were from New Jersey, Connecticut, or Pennsylvania. When I made a Venn diagram where T was the 15-year-olds and N were the New Jerseyans, you'll find that no one in the 15-year-old group comes from New Jersey. No one in the New Jersey group is 15. So I had to make the T circle over here and the N circle over here, with all the T names in one circle and all the N names in the other circle, and there were no names in both. It is possible to make interlocking circles as long as you leave the section in the middle blank. But of course it's much easier to just make the circles so that they are disjoint, not joined. And of course the C and the D stand for Carl and David, who are 16 and not from New Jersey. To answer the question, who's 15 and lives in New Jersey, the answer would be no one. The intersection is empty, which is what happens when you have disjoint sets. The union, however, is everybody in T with everybody in N, and there's really no way to show the union in a nice way except to just shade in both circles if you want to, even though they're not connected. Finally, it is possible that one circle might have to be drawn completely inside the other circle. Suppose we're in bunk 1 again and we look at their swimming stats. You can pass the deep water test or you can pass the lifeguard test. To be a lifeguard, a person has to pass the deep water test first, so there isn't anybody in the lifeguard list who isn't also on the deep water test list. If L stands for deep water, don't ask me why, it makes no sense to me. Oh no, I take it back. L is for lifeguard, gee, am I clever? And W is for deep water test. Then basically what we did was we put the lifeguards inside the deep water testers so that we could show that all the lifeguarders are deep water testers also. And again, because red and blue make purple, I made B, C, and G be purple. How cute is that? And little David and little Harry, who didn't take the deep water test or the lifeguard test, are again outside the circles. Why was D placed in the upper right-hand corner? No reason. You can put a letter anywhere in the correct circle or out of the incorrect circle. Since L is inside W, the union of L and W, if you take all of L and all of W, all you get is W. If you take L intersect W, which is everything that's in L and in W at the same time, you get L.